The penicillins are one of the oldest of these beta-lactam antibiotics. Actually, they are the first antibiotics used in pharmacology back during the Second World War. Now, for the mechanism of action, you are learning that all lactams will work the same way, which is actually three words. All lactams bind to penicillin binding proteins. That is your PBPs. Penicillin binding proteins. Now, this is the first thing that you need to remember for the penicillins. It's actually a term that all microbiologists like. And what these PPPs are, that they are actually enzymes that allow the cross-linking of the bacterial cell wall. The cross-linking is a more biochemical term. It is called as transpeptidation. So you have got the next thing that you need to remember is that penicillins, they bind to the PVPs and they inhibit the cross-linking, which is termed as transpeptidation. They inhibit transpeptidation. So the three words that are clue for all the lactams is that they bind to the PVPs, they inhibit the transpeptidation, and they prevent the cross-linking of the bacterial cell wall. Now that is the mechanism of action. And once you know the mechanism, that fits all really over here. The next thing that you need to remember is, or you need to see is, what are the primary modes of resistance to the lactams? First and foremost, it's the production by the bacteria through a plasmid mediated mode of resistance of penicillinases. Penicillinases, these are also called as beta-lactamases. Now what are these? These are the enzymes that are produced by the bacteria, and these enzymes would cleave the actual square ring that we saw in the lactam structure on the previous slide. Now imagine a chemist who tries to develop a drug that is beta-lactamase resistant by altering functional groups around that bond. Then a new mode of resistance arrives from this. It is a structural change in the penicillin binding proteins. It's the ultimate here actually. Penicillin binding proteins being the target for all lactams. And if the bacteria is successful in changing the shape of the PBP, then there will be no way for that lactam antibiotic to recognize its target and do its antibiotic work. This is the worst form of resistance we have. It's generally referred to as, thanks to the bug that develops it, as MRSA. That is your methicillin resistance, and SA stands for your Staph aureus. Now this is the bacteria that actually developed the mechanism of resistance towards beta-lactamase resistant antibiotics. Every time you change PBPs, lactams are useless. So this is where we are all left with one cell wall synthesis inhibitor to use, which is the drug vancomycin, because we all know vancomycin does not contain the beta-lactam ring. Now the third type of resistance is a change in the porin structure. Now what are these porins? These porins are only relevant for the gram-negative bacteria. The gram-negative, because gram-negative bacteria are those bacteria who only have the issue of having not only a cell wall made up of peptidoglycan, but also a periplasmic space, an outer wall made primarily of lipids and sugars, which require little channels called porins to exchange foods and junk literally between inside and outside. Well, for our drugs to reach the cell wall, they need to cross this outer wall, and they need to use the porin channels. So what these gram negatives do is, particularly like your Pseudomonas. This is a very nasty bacteria and a very smart one, to say the least, is that it can change the shape or change the structure of porins and then cause all the penicillin that has the activity on this bug to become absolutely useless. They can then not reach the actual cell wall. So as you look at these modes of resistance, just to reassure you, let me just show you how they were mentioned in the earlier table that I was discussing. Right. This is the earlier table that I was discussing. You see how for penicillins and cephalosporins, we talk about production of beta-lactamases. That is the first mode of resistance. They break the beta-lactam structure. Then the second is change in the penicillin binding proteins, right? This is the second one. And what we call as MRSA. And the third is change in the porin structure. So as promised, everything is written in this table.